Hello everybody, welcome back. It's your boy Dr. Sarian back at it again with another video on the YouTube. I have gained subscribers, which is pretty cool. I have gained so many. I am extremely grateful to the 3, 4, I don't know, 4 probably, maybe even more, like 4 people that subscribe to me and also watch my videos a whole ton. Very big respect. I enjoy you. Very cool. So today, oh yeah, I forgot to do my intro again. So I'm Dr. Sarian. I come from 10A. It's a grade in a school. Yeah, very cool. So today we have a wonderful project again, which is going to be the, what's it called again? Yes, the servo control, no, the remote controlled servo and piezo. Very cool. Actually, no, is it a piezo? Oh, that's a buzzer. It's an ordinary buzzer. It's fine. So the layout is I'm going to explain right now. I'm just going to casually do this. So this is what we have right over here. Now the components that we are going to require. Wait, what? No, the components that we need are well, this, aka the remote control. It's an infrared remote control. And we also have the breadboard over here to make everything a little bit more organized. We also have the IR receiver, which the remote control can send signals to, and well, the signals that get taken in and also get sent to the Arduino. We also have a bunch of jumper cables. We have both female and also male jumper cables. Right over here are the female ones that are being used. Also, we have the buzzer right over here, and we also have this guy. I'm not sure you can see it, but hold on, there we go. So this guy right over here is the servo that we're going to use. It's a micro servo of 9 grams SG90 Tower Pro TM. That's very cool. I don't know what that is, but epic. So we also have the Arduino and the USB cable, just because that's how it functions. I've explained it multiple times in recent videos. You guys can check that out so I can gain more views. Seamless plug. But let's get right up into what we're gonna do. So I don't know how to explain this, but this current setup basically doesn't work. I don't know how, but somehow my remote doesn't work. I don't know how, but like, yeah, I've tried it multiple times, I've experimented, and it does not work at all. So I will be demonstrating the code and also how it works via tinkercad, which is an online, it's a browser-based, maybe even an application, who knows, but it's basically in a browser. You can just make little projects like these for free. It's very advanced. It's really good as well. So I highly recommend you to use it if you want to try this kind of stuff for yourself or experiment with more and greater things. So right over here, I'm going to explain this just a little bit, and then we'll go into seeing the video. You guys can see the application open right over here. We'll see the video and a little bit of extra information. Right over here in Google Chrome, however, we're going to demonstrate the code again, which should be better in terms of explaining what happens, I guess. Who knows? Alright. So right over here, we have the IR pin, which is connected to both the voltage and also the ground. We also have this right over here, the orange cable connected to pin number 11, which is the IR pin. We're going to check the code out for that. We also have the ground and power connected. We are using 3.3 volts, so we don't accidentally blow up the breadboard or like the components. Actually, a little bit of a story. I accidentally made this heat up a bunch, which is kind of scary, I guess, for its health. Right over here on the piezo, however, we are both connected to the ground. I can't. All right, hold on. Yeah, we're connected to the ground on this side, as well as pin number 4. I have accidentally put that on 3. I'm gonna change that right over here. Yeah, so we put it on pin 4. Check out the code in a bit, I guess. So right over here, we also have the servo, which is connected to both the breadboard and the Arduino. Now on the Arduino side, we have pin 9 connected. This is pin 8. I am an absolute buffoon. Hold on. There we go. Now it's connected to pin 9, which is basically the input pin and the output pin. Actually not. It's an input pin, I guess, for the code. Electricity is fun. We also have it connected to ground on the breadboard, as well as to the power on the breadboard as well, which is pretty cool. Let me check if there's anything that I forgot to explain. I think I've got everything explained. We also have both ground and voltage connected to the breadboard via the weirdly brownish colored wire, as well as the yellow one. Yeah, so that's basically it. Alrighty, let's get into the code, I guess. Why not? Hold on, let me just casually change USB with my mouse USB, just so I can easily do this. Very cool. Right, let's get to the code. Right over here, we have the include irremote.h as well as the include servo.h. Now this is basically the code that we're going to get from the servers. Is it a server? I guess it's a basic C++ code that we can just acquire using this kind of command. Yeah, very cool. Yeah, this basically is for the IR remote and as well as the servo, like the code, as you can see right over here. Now, we are also setting up for the pins. We have int IR pin equals 11, which is the pin for the IR sensor, which is, which is this little thing right over here. This is an, what's it called? This is a universal one, I think. Yeah, so it's pretty cool. Just put that down right there. And right over here, we also have the int servo equals 9, which I've said before. We've connected pin 9 with the servo, just so we can have the servo working. And as an added note, we have int speaker equals 4, which is the pin for the speaker, which I've also explained. Now, we're going to go into right over here, IR receive, IR pin. This is basically for the IR code to receive the inputs from the IR pin, which is pin 9. Just, so it works, I guess, so we get signals and such. We also have decode results, so we have the results from the signals decoded, so we can utilize them way easier than, just way easier. It's a very good quality of life. It would have been too hard, I would say, if we were to not decode it. Maybe not even working as well. Who knows? We also have servo, my servo. We just set up the servo. Right over here we have void setup, line 12 till 18. Now this is pretty important stuff, I guess you could say. We have serial begin 9600, and on line 15 IR receive, enable IR in. This starts the receiver, just so you can get the signals, I guess. Right, on pin number, on line 16 we also have my servo.attach servo, which if we've seen right over here, in servo equals 9. So this basically attaches the servo on pin 9 to the servo object, just so the servo is actually connected to the Arduino. And now this is the extremely important thing you need to know: void loop. Inside this void loop, however, is kinda extreme things that you could take notes, I guess. I've struggled with this just a bit because something didn't work, aka the remote, which really put me in a bad mood for over several days. Right, so over here we have if I receive dot decode and results. This is basically decodes what the signals are. We also right over here, I'm getting stutters and stuff. Yeah, so right over here is the serial.print in, ln. This basically prints out the results value in hex form on the monitor right over here, as you can see in the left side of the screen. Yeah, serial port unavailable. Yeah, basically this is it. This is basically the monitor where you can just get the results value hex and such. We also have iReceive.resume, so the code resumes after you put in a signal, which is pretty cool. Now, right underneath this, however, is if results value equals 0xFF52AD. Now, previously on the LED controlled remote, we have seen 0xFF52AD. This is basically to put in a hex code onto this kind of code, I guess. This is when results value is equivalent to 9 on the IR remote. If you just send out a signal from the 9 button, you get this. So basically you can do the code, I guess. This also varies within the signals that you send, so you need to be very careful about it as well. Right over here we have let's explain it right over here first, however, before we go into that. Okay, so we have my servo.write 0. This basically puts the servo in what's it called, at the 0 angle, like the base angle, so it's really not anywhere, it's just facing up, which is cool. We also have digital write speaker low, which basically means that the speaker is going to be in low mode, aka it's not going to get turned on and no one's ears are going to bleed. We also have delay 1500. This basically delays the code so we don't have instant inputs or instant outputs and whatnot. We also have right down here, finally reaching it, if results value equals 5F5AA5, which is button 6 on the remote. Yeah. And right over here, below it, just 2 lines below it, we have my servo write 180. Now this is extremely important if you want to move your servo. The servo moves in a kind of an odd manner, which basically, if you put in a number right over here, basically the servo spins at the angle, at the degree of this number right over here. So let's say you were to put in 90, it will spin 90 degrees, which is pretty cool. I've put in 180, so it'll spin like 180. We have also digital write speaker high, so the speaker gets it turns itself on, which is pretty cool, and delay as well. And we also have delay, which is well, I guess that's the what's it called? Yeah, that's the code. Yeah, that's the code. That's it. That's pretty much it. It's 41 lines of code with that literally it. Yeah. So that's basically it for the code and also for the setup, kinda. We're gonna go see the video now. And this. Oh, I also forgot to say something right about this one. So right over here we have for the servo and also for the IR sensor what needs to be connected on. Like, as you can see from here, we have like 3 prongs on the IR sensor, and it needs to be connected to well, the proper thingies that needs to be connected to. Yeah. Right over here on the rightmost side on the IR sensor, we have 3.3 volts, aka the plus sign on the breadboard. We also have in the middle right over here GND, which is the ground. I've also put that on the breadboard, and we also have on the rightmost side of the IR sensor where there's an X. Yeah, you have to mind that as well. Is for the pin. Now, for the pin is basically for getting the inputs. Actually, no, not the inputs. Getting the signals into the Arduino. Yeah. Right over here for the servo, however, let me just unplug this real quick. Get this right down there. Right. So right over here on the servo, we have a brown. Hold on. We have a brown, orange, and red cable. I don't think you guys can see it, but right over here on the upper part, we have brown, which is for the ground. We also have red, which is for the volts. It says right over there to put it on 5.5 volts, which makes it function well. We also have the orange line, which is the bottom one, as the pin. Now, basically, to tell it apart easily, I suggest you just look at where the brown and the orange ones are. That's basically it. Yeah. So that's the image. That's just a little information that I forgot to mention. Right over here, however, we have the video. Don't mind the title, it's funny. Alright, it's gonna be like some sort of reaction kind of video, so let's boot up the small camera. And let me just increase this in size so you guys can see it more. Alright, we're gonna go through this once where I just don't talk, I guess, and let me just increase the volume so y'all can hear it. I'm going to be losing my ears, but it's fine, I guess. It's a cool, funny video. Alright, don't mind the background noise from this video as well. Righty, let's get into it. Yeah, so that's basically the video. My ears hurt, so right over here we're gonna debunk what's happening basically on this right over here. Hold on, let me pause the video. Right, so right over here we can see that. How do I get rid of this? Damn, it's very big. Yes, right over here we have the Arduino connected to the breadboard, so basically the code functions, I guess. Right over here we also have the. Hold on, let me move it back. I am very dumb. Right over here we also have the IRR receiver, I guess. The sensor, I guess. The signal receiver. Yeah. Right over here we have the receiver. Yeah, very cool. We also have the servo motor and also the buzzer. And we also have the line of code that we used and we also discussed, which is partially visible in this little bottom left corner of the screen. Right. I'm pointing to that. I've also tested it out multiple times just so it works. And at this part right over here, the motor spins 180 degrees, and the buzzer makes a very cool sound, just a loud noise. Very cool. Alrighty. Also, yeah, I forgot to. I think I already mentioned it, but like my my remote doesn't work. So is it my remote? I don't know. There's something doesn't work with my setup, so I just had to borrow someone else's. So I went to school, got myself an Arduino. I just used it in the room. Quickly made this 1 minute video and just left. So that's very cool, I guess. Alrighty. We're gonna continue this video right over here. So the buzzer makes a sound. I think you guys could hear it potentially from the little section that I just left blank. Yeah. We also have the servo motor also spinning right over there. And this right over here is the demonstration of what happens with the serial motor. So right over here we have put in FF5AA5, which is button 6, which turns the thing on, essentially. Yeah, so right over here, basically, I think you guys can hear like a subtle noise from the buzzer. And we also have right over here, I am very slow. My direction is very slow. Hold on. Yeah, FF52AD. I'm a very fast man. Right. So that right over here, FF52AD basically turns the whole thing off, which is really cool. Yeah, right over here we have the servo motor again, just turning it on and off. Yep, and that's pretty much it for the video. I feel very unsatisfied with it, so as an added bonus, I'm going to demonstrate with y'all what it's supposed to do on Tinkercad, which is basically this right over here. It's, I've said before, a browser-based / application-based, I think, like Arduino simulator, I guess. I have terribly made this contraption, so please excuse the messiness, but basically we also have the same code running. Yes, we have put it on different buttons, however, where to turn it off, wait, what? Oh, yeah, it's kind of scuffed. It's kind of a scuffed code, but you know what? That still works. Right. So we have pin 4 on the buzzer / piezo. We also have pin 9 on the pin 9 on the servo motor. We also have pin 11 on the IR receiver. Oh, it's a sensor, but same thing, I guess. Infrared receiver, infrared sensor, yeah, same thing, kind of. Alrighty, let's demonstrate this whole contraption thingy. I don't think you guys can hear it, like the buzzer just making sound. So I honestly don't know, but let me just casually do this right over here. Thank you Arduino, not Arduino, Tinkercad. I know what the debugger does. Yeah. So right over here we have the code functioning. We also have the serial motor right over here. Just see it. Righty. As seen right over here, we can turn on the piezo with just pressing button 0 on the remote. Ow, my ears. Oh, ow, ow, ow. That hurts. Ouch. Yeah, so basically you guys can see the thing's making noise. Yeah, and also the motor just did like a spin. Hold on, I need to turn it off. Oh my god, that is extremely loud. Oh wow. Yeah, so it does a 180 spin. It's the 180-degree spin, as I've previously mentioned as well. It does a spin of, depending on this, it's basically the degrees that's going to spin. Yeah, so basically when I press 7, it turns off the piezo, but when I press 0, it turns on the piezo. It's also going to spin at 0 degrees when you press 0, when you press 7, when you press, wait, what? When you press 0, it basically goes back, it reverts to position 0, I guess, which is the opposite of what's happening over there. And yeah, let me just turn it on again. And there we go. Wait, hold on. I've pressed the wrong button multiple times. Hold on, can this? Ouch. Yeah, there we go. So it's spinning currently to the position of 0. You guys can see it, it's a bit of an odd angle than before. Yeah, that's basically it. Right over here we have the speaker also blaring. Yeah. We're gonna press, ow. Okay, we've turned it off. Yeah, so that's basically it for the simulation and the code, I guess. Yeah, that's basically how it's happening. That's basically it. Yeah, very cool code, I guess. Very cool setup. I just hear a sneeze, but yeah, it's fine. Yeah, I guess that's basically it. Did I even forget to mention anything? We've talked about the code, we've talked about the components. I guess that's it. Hold on, let me just casually check this. I am tremoring in my seat as of this moment right over here. Alright, project and components. Yeah, this is basically the servo motor control using the remote. Notice the buzzer sound, but I could not care less. The buzzer sound was way too easy. You just had to add like, wait, hold on, 1, 2, 3. It's basically 3 lines of code extra, which is hilarious, honestly. I thought it was going to be like 7 million, but you know, it's good. It's good fun. Alrighty, I guess that's it. That's all from me. Hold on. my camera, my small camera. It's wonderful. It's so cool. It's so wacky and weird, silly. It's so goofy. How do I know so many adjectives for weird? Yeah. I guess that's it. Thank you all for watching. Be sure to hit that like and subscribe. Leave a comment. Click the bell. Yeah, I'm doing YouTuber stuff because I know there are viewers, which is so cool. I'm like so popular. I guess that's it. Sad that I can't demonstrate it live, which would have been really cool. But yeah, I guess that's it. See you all in the next video, which is probably never. Also, I don't know how to do an outro, but like, goodbye. Yeah, goodbye. I'm a boring person.